Dear students, today we can revise the very important topic motion in a straight line. Keep in mind, from this chapter we can assure about minimum 1 or 2 questions for NEET and JEE main, maybe more than 3 questions for Kerala entrance examination. At first we can just compare the two terms distance and displacement. The distance is nothing but the total path length travelled, but displacement is the shortest possible distance between the starting point and the end point. And hence, here d1 and d2 are the distances and s can be treated as the displacement. And keep in mind that distance can take many values, but the displacement is a single value. See, the distance never decreases with time, but the displacement reason in some situations that body may move towards the initial position. The distance can never be negative or zero, but the displacement can be positive, negative or zero. Go through the some examples. If the particle is moved through the circumference of a semicircle, and we can assure about the displacement is the diameter, but the distance is pi r. If a body is thrown upward and come to the initial position, the distance travelled become double of its height, but the displacement becomes zero. If a particle is moving along the inclined plane, both the distance and displacement got the same values. In general, the distance is greater than or equal to displacement. We can go with one important question. Read the question carefully. A man has to reach his office, which is 50 meter due south, 30 meter due east, and 90 meter due north from his home. Determine. 2 questions we have to answer. The distance he has to walk to reach his office. And the second question, the magnitude of his displacement from home to office. We can draw the figure at first. And if we take his home as origin, at first he has to move 50 meter due south, so it takes the position A. Then 30 meter due east takes the position B. Then 90 meter due north, so takes the position C. The first question, what is the total distance? So without considering the sign or direction, we have to add the 50 plus 30 plus 90. But the displacement, that is the shortest. So we have to find what is OC. Vectorically you can written as OC is nothing but equal to vector OD plus DC. But OD is nothing but AB. DC is nothing but BC minus DC. So here the right angled triangle, and hence we can written as root of OD. In magnitude it becomes a 30 meter square plus DC square, that is a 90 minus 50, and hence you get the answer as a 50 meter. Then we have to look into the differences between the average speed and average velocity. Keep in mind the average speed is the total distance traveled by the time interval. The average velocity is nothing but the total displacement by the time interval. Like distance, average speed is a scalar. Like displacement, the average velocity is a vector quantity. The distance got many values. Like that, the average speed got many values, and it never be 0 or negative. But here the velocity is single valued, and it can be negative or 0. We should approach carefully the meaning of average speed and average velocity. See, one important point: the average speed can be equal to the magnitude of average velocity only when the motion along a straight line without change in direction. If you just plot a graph between distance in bracket displacement and time, the slope of the chord during the given interval of time gives the average speed. So the V average, take the value as delta S by delta T. So the tan alpha, take the values as the slope. If it is a distance time graph, it is average speed. If it is a displacement time curve, it is average velocity. So keep in mind. A good aspect, a very important problematic situation: if a particle goes from A to C, and suppose the S1 distance travels in a time t1 with a velocity v1, and S2 distance in a time t2 with a velocity v2, then what is the average velocity if t1 is equal to t2? You can use the same formula, the total displacement by time. By putting the relevant factors, we get the very important relation with equal time as v1 plus v2 by 2. That is nothing but the arithmetic mean. If S1 is equal to S2, then the average velocity become 2 v1 v2 by v1 plus v2, and is said to be the harmonic mean. So the very important is two situation. We can go with one important question regarding the average speed. Please read it carefully. A particle covers half its journey with a constant speed v, half the remaining part of journey with a constant speed of 2v, and the rest of journey with a constant speed of 4v. Then its average speed during the entire journey is. So we have to find what is the average speed. At first we can plot it. Exactly half distance S by 2 with the velocity v. The rest half, out of that, half with the velocity 2v and half with the 4v. Then the average speed, it becomes so simple. The total distance by time interval. The total distance is taken as S. The time factors are not given, but can be simply find out as this distance by velocity. You get the answer. So again, we should differentiate between instantaneous speed and velocity. But instantaneous means it represents the velocity at a particular point. With direction we can say instantaneous velocity, but its magnitude, that is called instantaneous speed. The velocity can be positive or negative as it is a vector, but speed can never be negative. And see the next very important concept. we can express it through an example. If displacement is given as a function of time, the time derivative of displacement will give velocity, and the modulus of velocity is speed. Say, as an example, the displacement is expressed in terms of time for a particle as a0 minus a1t plus a2t square. Then we can find the velocity as the first differential of displacement is equal to minus a1 plus 2a2t. But if we take t is equal to 0, we take the value as minus 1. But the instantaneous speed become the plus value a1, the modulus of velocity. See the another very important point. The slope of displacement versus time graph gives velocity. Look at the graphs. How we can find the instantaneous? And see the case. Here the plotting is with the displacement time curve. So at a particular time, you just take the tangent with respect to that point, then we can find the instantaneous velocity. If we are with the velocity time curve, z, the velocity is nothing but equal to the displacement by time, then ds can be written as v into dt, then s take the form as integral v dt. But from this graph, if you take the area with the proper algebraic sign gives displacement. With the proper algebraic sign gives displacement, while without the sign gives distance. So there is a very important point regarding instantaneous velocity and speed. We can go through with a very good example. A previous year question. If position vector varies with time as r is equal to sin ti plus cos tj plus tk cap, where t is in seconds, then find the velocity and speed at t equal to pi by 2 seconds. So here r is given, but it depends upon time factor, and hence easily we can find the velocity function by differentiating with respect to time. So because of the first differential, we get the value cos ti minus sin tj cap plus k cap. But we need to find what is the value at t is equal to pi by 2 second. We can put the value, then in vector form we get the velocity with the direction as minus j plus k meter per second. But the instantaneous speed means the magnitude of velocity, it is root of minus 1 square plus 1 square. You get the value root 2 meter per second. Then the very important another one, what is the difference? What is the meaning of average and instantaneous accelerations? Look here. The average acceleration means the change in velocity per the change in velocity per time interval. But here the instantaneous, if the delta dt tends to 0, the dv by dt is taken as the instantaneous acceleration, or can be written as, if we express that velocity as ds by dt, we can say the second differential of displacement with respect to time, or the first differential of velocity with respect to time, that is called acceleration. The next point, it is a very, very important point. If velocity is given as the function of position, we can express that dv by dt as dv by dx into dx by dt. You already know the dx by dt is velocity, and hence we can express the acceleration as velocity into dv by dx. acceleration as v into dv by dx, a very important concept. And see some important points regarding the average and instantaneous accelerations. The slope of velocity versus time graph that gives acceleration. The acceleration which opposes the motion of body, that is called retardation. Its meaning, it should be so clear for you. The coming important points will give a very good idea between acceleration and retardation. So look at the figure here. The motion of the body is along the positive x direction. If the acceleration is along the positive x direction, but if the acceleration is opposite to the movement, then we can call it as the retardation. And keep in mind, the sign of velocity represents the direction of motion, but the sign of acceleration only indicates the direction of acceleration. That is a very important concept. If velocity and acceleration both are having the same sign, the magnitude of velocity is increasing. And if both have opposite sign, the magnitude of velocity is decreasing. It is a very important concept. See, a very good problem for you. The acceleration of a particle moving in a straight line varies with its displacement as a is equal to 2s plus 1. Velocity of the particle is 0, say at 0 displacement. Then find the corresponding velocity displacement equation. So here it is expressed as acceleration as 2s plus 1 in terms of velocity, but we have to relate between the velocity and displacement. A very good concept, a very, very important concept. A is given as 2s plus 1 here, but we know the acceleration is dv by dt, but we already expressed that acceleration in terms of velocity and distance through the relation v into dv by ds. That is given as 2s plus 1. We can rearrange it, become integral v into dv, take the value equal to 2s plus 1 into ds. If you integrate, you get the value, the left hand side as v square by 2 and is equal to right hand side 2 into s square by 2 plus s. We have to integrate between the limits 0 to s to the right hand side. Then you get the value v equal to root 2s into s plus 1. The kinematic equations, the very, very, very important. We can go through as v is equal to u plus ad, s is equal to ut plus half t square, v square equal to u square plus 2as, the displacement in the nth second. The next, a new one for you. The displacement is the average velocity into time, but keep in mind are applicable only when if the body is under constant acceleration. So s take the value as u plus v by 2 into t, a very good concept. So keep the very important concepts. You have to do maximum number of problems based on the kinematic equation. And see here with the two important questions. And here a car accelerates from rest at a constant rate alpha for some time, after which it decelerates at a constant rate beta and come to rest. If the total time elapsed is t seconds, we have to find what is the maximum velocity reached and the total distance traveled. See, the initial case, it starts from rest. The final velocity, say it's a maximum velocity as V max in a time t1 by traveling a distance s1, then you can apply the first relation V equal to U plus AD. You get the value as alpha, take the value equal to V max by t1. The second part, the beta takes the value as V max by t2. Then you can rearrange and we can find the value for t1 plus t2. And here it is given as t seconds is equal to V max into 1 by alpha plus 1 by beta, and hence maximum velocity we can find as alpha beta by alpha plus beta into t. We can use the last kinematic relations. At the first case, s equal to u plus v by 2 into t, and here the first part s1, that is the displacement, occurs equal to the initial velocity 0 plus the final velocity V max by 2 into t1. For the second case, the initial velocity is the maximum, the final velocity is 0 by 2 into t2. Then you can just add the total distance s is equal to V max by 2 into t, and you can put the value V max here as alpha beta by alpha plus beta, and you get the value alpha beta by 2 alpha plus beta into t square. So that is a very important concept. And see another good concept. Two cars start off a race with the velocities 2 meter per second and 4 meter per second, travel in straight line with uniform accelerations 2 meter per second square and 1 meter per second square respectively. What is the length of the path if they reach the final point at the same time? So read the question carefully. We can get it in a very simple concept. Now here the distance traveled them for the time t are same. Then for the first particle we can written s. For the second particle we can written s. But both s are same, and hence you get the time as 4 seconds. Then you can put it in any one of the equation. You get the value as a 24 meter. That is the answer. Then we have to deal the three group of graphs, and here the position time graph. The position time graph. We have to deal 5 different types. If the position time graph, it is parallel to x-axis, that means the slope is 0. That means the velocity is 0. The body is at rest. Look at the second graph. The slope is constant. The velocity is constant. The body is under uniform motion. And here, the third graph, if you take the slope at any point, or we can say the theta is decreases with the time. That means the velocity decreases with the time. We can say it is a non-uniform motion. Look at the fourth graph. And here the angle is goes on increasing. The tan theta slope is increasing. That means velocity is increasing. Another non-uniform. The fifth one, the angle is greater than 90. The slope is negative. The velocity is negative. The velocity is constant but negative. Uniform motion. So the very important concept. So by using this picture, you get every graphs regarding the position and time. A similar interpretation with the velocity time graph. And here also the 5 graphs are waiting. At first one theta equal to 0 means the slope is 0 means the velocity is constant means acceleration is 0. The uniform motion. If you look at the second, here the slope is constant. The acceleration is constant. Uniformly accelerated body. The third one, like in the previous case, we can say the theta is goes on decreasing. The acceleration goes on decreasing. But keep in mind, it is not a retardation. It is coming later. The fourth one here, the slope goes on increasing. And we can say the acceleration goes on increasing. The fifth one, the theta is greater than 90 but negative. Uniform retardation. Look at the third graph, the acceleration time graph. And keep in mind, the area of the acceleration time graph will give the change in velocity. And here the constant accelerated curve, and here the uniformly increasing acceleration that is representing as the second curve. The very important problematic situations, the motion under gravity. While solving that such a problems, I am dealing with a special sign convention with respect to NCRD. Every movement along the right of the Cartesian coordinate we can treat it as positive. The left as negative. The upward motion as positive. The downward negative direction as negative. See, for a dropped body, we can easily turn the height as half gt square, the velocity as a root 2gh, and h is equal to v square by 2g. For a dropped body, h is proportional to t square. Then the distance fallen in time at t, 2t, 3t, etc. will be in the ratio 1 square, 2 square, 3 square, the squares of integers. Another very important problematic situation. The distance fallen in the nth second, that is half g into 2n minus 1. So it should be in the ratio 1:3:5. So you should go through these 2 points, the very, very important one, and see the 3 important graphs for a body projected up from ground. And see the displacement time curve, the velocity time curve, and keep in mind, and if you take the area with the proper sign, the displacement becomes 0. So there is a curve here. See the acceleration time curve, and here the acceleration due to gravity is negative but constant. A very important concept. See, in the normal cases, we neglect the air resistance. What happened if we consider the air resistance? During the time of ascent, we get the value root 2h by the acceleration as g plus a. For descent, it becomes g minus a. And keep in mind, the time of ascent is less than the time of descent, or time of descent is greater than the time of ascent. And see the another crucial concept. If a body is projected vertically upward with some initial velocity from some height, and see the equations of motion. A very important concept. We can go with 2 questions also. A body is released from a height and falls freely towards earth. Exactly 1 second later, another body is released. Then what is the distance between 2 bodies 2 seconds after the release of the second body? Please read the question carefully. So we can just find what is the distance traveled by the second body for 2 seconds. Then we can assess one thing. The first body must move through a distance of a time of 2 plus 1, 3 seconds. Then you can just take the difference. And similarly, another question. A ball is thrown upward from the top of a tower 40 meter high with a velocity of 10 meter per second. Find the time when it strikes the ground. We discussed the simple matters. So minus h, take the value as ut minus half gt square. If you solve the quadratic equation, you get the answer. Okay, Thank you. God bless you. Take care.